Hello, everyone. And welcome to a second session on Pascal Triangle. I told you this would be a surprise for you. It's a bonus session again. And what I'm going to show you now is that we can use Pascal Triangle in a way that I believe most of you haven't heard of before, which is expanding sines and cosines. Sines and cosine, what do they have to do with Pascal triangle? But let's see. Um, okay, so let me go to the hovercam and show you something that you already know. For example, you learn how to expand sine and cosine expansions. I bet all of you already know that I can expand sine of 2x and cosine of 2x. You learned that in trig. You know that sine 2x is 2 sine x cosine x. And cosine 2x comes in 3 flavors, right? One of them I'm interested in, which is cosine square x minus sine square x. Notice that you can write it as 2 cosine square x minus 1 or 1 minus 2 sine square x, but this is the one I am looking at. Now we look at Pascal triangle. When I expanded sine of 2x and cosine of 2x, do you see that this guy, this 2, is this one? And that's a 1, and a negative 1 are these ones. So what observations can we see? First of all, when I expand cosine nx, I start with cosine to the power of n of x. This 2 and that 2 match. This 2 and this 2 match. I'm sorry. I'm talking cosine. So I start with this 1 cosine square minus 1 sine square. Where did the sine square come from? We'll see that in a second. And the one in the middle is the 2 that you see here in 2 sine x cosine x. Let me show you how I am going to expand sine 3x and cosine 3x, and then you will see how to do it for anything else. Sine 3x. I want you to think of the first entry. So for example, I am in 3, right? So this entry and this entry are for cosines, and that entry are for sine. But how do I find the power? Remember when we said head and tail in binomial distribution? Here it's very, very similar. This is cosine cube of x. This one would be cosine square sine x. This is cosine x sine square x, and this is sine cube x. Oh, so the first entry is the highest power of cosine. Then I decrease the cosine power by 1 and increase the sine by 1. Decrease the cosine by 1, increase the sine by 1, and so on and so forth. I know it's a little unclear for now, but let me show you how I'm going to expand sine cube x. The sines are the even entries, like second and fourth. Here it was the second. Here it would be the second, the fourth. Here that would be second, fourth, and sixth. And the cosine are the odd entries. So the first entry I see is 3. So I write 3. Notice, this was cosine cube, So this is cosine square sine x. So I can write it as sine x cosine square x. Then I'm going to jump 2. So I'm going to, first of all, I see a 1, and you always alternate the sign. So the first entry is positive, the second entry would be negative. And this one, I increase the sign by 2 and decrease the cosine by 2. Why? Because I jumped 2 steps. So that would be sine, notice it's 1, I don't write the 1. I increase the sine by 2, it becomes cosine cube of x. I decrease this by 2, so there is no cosine. And that's the expansion of sine 3x. Let me expand cosine 3x, and then that would be very simple for you to see. I take these two entries. The first entry is the highest power of cosine, and the coefficient is 1. So it's cosine cube of x minus, I jump and I come here. So this is, I decrease the cosine by 2 power and increase the sine power of for 2, and the sine wasn't there. So I get cosine, I'm sorry, minus 3 cosine x sine square x. How do you like that? So now, not only you don't need to memorize this, you can get it from Pascal Triangle, which I haven't seen. Well, maybe, of course, I'm not saying that I've seen everything, but I haven't seen anybody explain it like that or find the expansion like that. Let's pick one. I mean, we did 1 and 3, so we can do 5 or 4 or 6. Let's take 6 so that you see it very clearly. Expanding sine 6x in terms of x. Notice these are in terms of x. You can expand them and make them like one of them is 2x and the other is x. You can do that, but this is the easiest way that comes directly from Pascal Triangle. I will start with this row. If I want the sine, I take the second entry, the fourth entry, and the sixth entry. So there would be 3 terms. What do you think the first term would be? Again, this is all cosine. This is 1 sine and 5 power of 5 for cosine. 3 and 3, 5 and 1. So I'm going to enter 6. This is sine x because this is all cosine. So sine x, but the sum of the powers has to be 6. So cosine to the 5th of x. And then the next term would be minus 20 sine cube x cosine cube x. And then 6. So plus, notice we alternate the signs. I'm going to increase sine by 2, sine to the 5th of x, and decrease the cosine by 2, cosine x. So easy, right? Nice. Now let's take cosine. Cosine 6x will have 4 terms, not 3, because I'm going to take the first, the third, the fifth, the seventh. So maybe we'll need more space. Okay, so the first one is cosine to the 6x minus 15 cosine to the 4th x sine square x plus 15 cosine square x sine to the 4 of x. And finally a 1, so minus, there is no cosine because I'm going to subtract 2, and all of them are sines, sine to the 6 of x. In fact, let me try to use Um, oh, I'm not sharing this with you. So let me, uh, okay, let me stop the sharing and then share the whole thing because I was sharing only uh, the hovercam. So let me share everything with you. And I'm going to go to, oops, okay, Wolfram Alpha. And then I'm going to expand, let's say sine with its 6x, right? 6x. One of them should be what we are looking for. Oh, it's the first one. I want you to look at the first entry. 6 sine x cosine to the fifth. 6 sine x cosine to the fifth. Minus 20 sine cube cosine cube. Minus 20 sine cube cosine cube. Plus 6 sine to the fifth cosine. Plus 6 sine to the fifth cosine. Now, let's change that into cosine. Oh, I'm sorry. Change that. It's easier instead of using the functions. And you can see it's not the same order we have, but we have a cosine to the 6x, right? Cosine. Oh, for some reason, it arranged itself. Cosine to the 6 minus 15 cosine to the fourth sine square plus 15 cosine square sine to the fourth minus sine to the sixth. And basically that's it. So now this is a new property of Pascal Triangle that you learn, and I hope it will become handy. Usually, I don't think you will need to expand sine to the 6 of x, but at least now you know, even if you forget sine 2x and cosine 2x, you can get it right away. If you want sine cube and cosine cube, which is sometimes not that easy, you can also find it. Um, I think I'm gonna stop here. There are other stuff, but I think these are the most interesting properties of Pascal Triangle. So we'll make that a short video, and maybe in the next videos I will show you some other expansions that are also useful, very useful in algebra. Okay, thanks for your time, and hope to see you soon. Bye.